Howdy. The bell rings in 10 minutes, or 9 minutes, but we're going to see what I can get done before that happens. So this is the tree diagram and tree and Venn diagram notes for probability. So with tree diagrams, we'll do something. We have an example like this. Bag A has 2 marbles, 2 red, 4 blue. Bag B has 1 red, 3 blue. A 6-sided dice is rolled to see which bag is chosen. If a 1 or 2 is rolled, a marble is chosen from bag A. If a 3 or higher is rolled, a marble is chosen from bag B. Okay, so the first thing that can happen is that we can either get bag A or we can get bag B. Okay, and so, can you read all that? And then when you're in bag A, you either get a red or you get a blue marble. And same story with bag B. You either get a red or a blue marble. And so the probability that you get either bag A or bag B, that has to equal 1. There's no other option for what can happen. It says a 6-sided die is rolled. If a 1 or 2 is chosen, a marble from bag A. If 3 or higher is rolled. So we're assuming if they didn't want them to be equally likely, they would tell you. So there's 2 out of the 6 ways and then 4 out of the 6 ways. So 2 out of 6. You can either tell me 2 out of 6 or 1 out of 3, and therefore this is 2 out of 3, 4 out of 6. Notice these 2 right here add up to 1. Then, okay, so now we're in bag A, and we have 2 out of the 6 there's a total of 6 marbles. 2 of them are red, so 2 out of 6 is 1 out of 3. And there's 4 out of 6 or 2 out of 3. Sorry, I just like to reduce the fractions when it's easy. And the probability, okay, so assuming that you're in bag A, the probability that you get a red was 1/3. The probability that you get a blue is 2/3. Now you're into bag B, and we have 1 red and 3 blue. So you've got a 1 out of 4 chance that you get a red, and a 3 out of 4 chance that you get a blue. So we can figure out each of these individual little probabilities. The probability that you get bag A is 1/3, and the probability that you get a red is 1/3. So the probability of getting a red out of bag A becomes 1/9. And so I find it helpful to write these down here. This, multiply here, and notice we multiply those to get this. Now I can multiply this, and I get the probability of getting a blue out of bag A is 2/9. And then this becomes, 2/12, which is 1/6. Sometimes if you don't reduce the fractions, then all of these have a common denominator, which can be nice, but okay, whatever. And then this one, when I multiply, I have 6/12, or 1/2. And it should happen that all of these should add up to 1 also, because there's nothing else that can happen. Either you get a red or a blue out of bag A, or you get a red or a blue out of bag B. This is what, 2/18, this is 4/18, this is 3/18, and this is 9/18. Let's see, do they really add? This is 6, 9 plus 9 is 18. So that sums to 1. So what is the probability that a red marble is chosen? Well, I can get a red here or a red here. So that becomes 1/9 plus 1/6. That's 2/18 plus 3/18. Well, that's 5/18. What is the probability that a blue marble, I keep saying marble is chosen? So blue would be, well, if it's not red, it's blue. So you could either say it's 1 minus 5/18, which is 13/18, but you could also get that here by adding blue and blue. And yes, sure enough, that is that 13/18. So now the next one says, what is the probability that bag A was selected if a red marble was chosen? This one's a little bit more involved. This is saying, what's the probability of bag A given a red marble? I'm out of control. Okay, so on this one, we have to use one of our formulas. So what is probability that bag A was selected if a red marble was chosen? I'm a little shaky on my probability. There's a formula. Okay, the probability of A given B is equal. Let me think about, so sorry, I should have planned ahead. This is the first video I'm doing. Okay, so the probability, if this is A and this is B, the probability of A given B. So this is the part right here that's both A and B. And so the probability that you're in here, assuming that we already know that you're here, is equal to the probability of A intersect B divided by the probability of B. So it's another way to think about this, and I probably will make another video on this part for a second. If I have 1, 2, and 3, and this is events happening, and I'm saying there were 2 of them that had A and B, there were 3 that had just B, there were 5 that had B total. So if I say the probability of A given B, so this is saying you live in the world of B, what's the probability that you also live in the world of A? Well, there were 2 out of those total of 5 in B that also lived in A. Okay, sorry, I had to refresh my memory there. So in this one, in this particular problem, we're saying find the, you know what, I need more paper. The probability of bag A given a red would be equal to the probability of their intersection, bag A intersects red, divided by the probability of red. Okay, so the probability of their intersection was bag A red is 1/9. The probability of red in general, well, we said that was 2/18 plus 3/18 is 5. Oh, it's right here also. Haha. 5/18. Or in other words, I should have the common denominator. This is 2/18 divided by 5/18. If I multiply by 18 over 18, that gives me 2/5. So this last question, what is the probability that bag A was selected if a red marble was chosen, is going to be 2/5. Or we could say 40%.